Hey, awesome Algebra 1 students. Let's work through more inequalities. So today we're going to be solving and graphing inequalities joined by and or. Last lesson we talked about and or and what it meant. So we're just sort of extending on that today. First of all, let's do a few exercises to warm up our brain. I have solve w squared equals 121 for w, and then graph the solution on a number line. With this one, I've got w squared equals 121. If I take the square root of both sides, that gives me w equals plus or minus 11. We have to take into account the positive and the negative. I'm going to fudge the graph just a little bit. And I'm equal to, so I've got a dot there and a dot there. If I have w squared is less than 121, I'm still taking the square root of both sides, but I get w less than plus or minus 11. Okay, I need to move that minus 11 over. And it gives me an and inequality. Okay, there we have our and. So that means w is somewhere between, 11 and negative 11. Sorry. If you think about it, if I square 10, I get 100. If I square 9, I get 81. If I square negative 10, I get 100. If I square negative 9, I get 81. So w is somewhere in between negative 11 and positive 11. If I squared 12, I would get 124. If I squared negative 12, I would get 124, which doesn't satisfy the inequality. And here we have w squared is greater than or equal to 121. Okay, square both sides. And let's look at our number line. Negative 11 and positive 11. If I do the same test as b, if I plug in 9 squared is 81, which is not greater than 121, so that doesn't satisfy it. 12 squared is 124, which is greater than 121. 144, sorry, I think I misspoke earlier too. 12 squared is 144. So all the numbers in between the negative 11 and 11 do not satisfy the inequality, but everything smaller than, bigger than, there we go. That all works. And this is an and inequality, and this is an or inequality. All right, quickly solve the equality x plus 7 quantity squared equals 121. If I take the square root of both sides, I get x plus 7 equals plus or minus 11. So if I subtract 7 from both sides, I get x equals 4 or x equals negative 18. 2 dots, lots of tick marks in between. Use your work from part D to quickly graph the solution on a number line to the inequality below. I know I have negative 18 and 4. I just need to figure out if I shade in between or outside. Bunch of tick marks. Okay, let's plug a number in and see. I love plugging in 0. So if I plug in 0 for x, I would get 7 squared, which is 49, and is less than 121. So that is enough to tell me that I need to shade, including the 0. 0 is a part of the solution, so I need to shade where the 0 is. Let's go ahead and quickly plug in a 0 again. Oh, we should give our answer here. Negative 18, x, 4. Plug in 0, and I get 7 squared, which is 49, is greater than or equal to 121. Is that true? No, it is not true. So I cannot shade 0 as part of my solution. I need to shade where 0 is not included. And this would be x is less than negative 18 or x is greater than 4. All right, consider the compound inequality. Rewrite the inequality as a compound statement of inequality. Okay, when we see them like this, they are and statements. Okay, so we need to write them as and statements. This gives me x, Pac-Man eats the x, negative 5, and x, Pac-Man eats the 4. So there's my compound statement. So I've got x is greater than negative 5 and x is less than 4. A sentence would be x can be any number between negative 5 and 4. Then if I graph it, I'm going to go open dot on negative 5, open dot on 4, and shade in between. Consider the inequality, the compound inequality, and rewrite it. I'm going to have another and statement. So 2x plus 1 is greater than negative 5, and 2x plus 1 is less than 4. And then solve each inequality for x. So subtract 1 from both sides. I get 2x is greater than negative 6. Divide by 2. X is greater than negative 3. Subtract 1 from both sides. 2x is less than 3. Divide by 2. X is less than 1.5. Cool? Of course, next we get to graph it. Actually, before we graph it, I need to write my solution to the compound inequality. I'm going to write it all together. So the first thing I write is my smallest value, which is going to be less than x, which will be less than 1.5. And you just make sure, Pac-Man's eating the x, Pac-Man's eating the x, Pac-Man's eating the 1.5, Pac-Man's eating the 1.5. So I've got my compound inequality. And then in a sentence, x can be any number between negative 3 and 1.5. You could have 3/2 there. That's totally fine. Negative 3, 1.5, and anywhere in between. Okay, so now we have an or statement, right? When they're written like this, well, this one has an or, so we know that your solution is probably going to look like this on your number line. So what must be true in order for the compound inequality to be a true statement? Remember the ors? So one of the inequalities must be true. That's what the or means. One of them must be true, or both of them can be true, but you have to have at least one, okay? If I look, can x be less than negative 3 and greater than negative 1? No, so both of them cannot be true, but just with the bottom line, or statements, at least one of the inequalities has to be true. Write a sentence describing the possible values of x. Oh goodness, sorry. X can be any number that is less than negative 3, or any number greater than negative 1. If you graph that on a number line, I'm going to shade that way or that way. Okay, given two more equations, solve each inequality for x, then write the solution to the compound inequality. So I'm going to subtract 4 from both sides and have x is less than 2. add 1 to both sides, and I'll have x is greater than 4. So x can be any number less than 2 or any number greater than 4. I should use the words. So graph the solution set. I've got 2, 4, greater than 4, less than 2. Pretty cool. Okay, here's some practices for you to do. Why don't you guys hit this page? I'm going to push pause and go through them, and then we can check our answers in the end. Okay, letter B was a tad bit tricky. So I'm going to talk about this one. This is a compound statement. It's an and, so I rewrote the left side of the inequality, and then the right side of the inequality, and then I solved it. But notice here, I divided by a -2, which I had to flip the inequality. And here, I divided by a -2, so I had to flip the inequality. But my solution still worked out to look like an and. I just wanted to point that out to y'all. Okay, try these 3. I'll be right back. Push pause. All right, we finished this one. Nothing too crazy that I can see that changed. So check out your answers and see if you need anything. All right, exercise 7, solve each compound inequality for x, graph the solution on a number line, pay careful attention to the inequality symbols and the and or statements as you work. So this is an or statement. I'm going to subtract 1 from both sides in that beginning, so x is greater than, there we go, x is greater than -5. And then for the next one, add 6 to both sides. And that gives me -6. Divide both sides by 3. I have -2. Cool. So it's an or statement. So to graph this, I need to marry those two inequalities together somehow. So we can look at it. You know, I have -5 and -2. They're going to overlap, and since it's an or statement, where they overlap is where your final solution works. So let's graph it. I have -5, open dot, shading all the way to the right, -2, open dot. Okay, they overlap, so your final solution is actually the -5 shaded all the way to the right with an open dot at -5. Cool. Moving on. Okay, let's try this one. I'm going to subtract 1 from both sides, which gives me x is greater than -5, and this is an or statement. So, hold on, sorry. I tried to erase something. X is greater than -5. Or statement, add 6 to both sides. 3x is less than -6. Divide both sides by 3. X is less than -2. Go ahead and graph these. It's an or statement. I'm going to have -5, 4, 3, 2, 1, 0. Open dot. X is greater than, and then open dot at -2, x is less than. It overlaps, so it's an or statement. My final solution is actually the entire number line, which is all real numbers. Okay, and the last one, go ahead and solve it. I have subtract 1 from both sides. X is greater than 3, and add 6 to both sides. 3x is less than -6. Divide by 3, x is less than -2. So let's see if these and statements can give us anything that overlaps. -2, -1, 0, 1, 2, 3. Open dot at -2, or open dot at 3, shading to the right. open dot at -2, shading to the left. They don't actually overlap. That and statement says that I need both of them to be true, and neither one is. So it's actually an empty set. Awesome. That's all I have for today. Good job.